I'm going to go ahead and break section 6.3 up into 2 points that we can cover online to save us some time during class. This part's going to cover fractions in lowest terms and multiplying and dividing fractions. There's going to be 2 questions that you should be able to answer by the end of this. The first one being, how are fractions written in lowest terms, and how are fractions multiplied and divided? We need to do just a quick review of what a rational number is. This was discussed in section 6.1, but it's a nice time to just quickly talk about it again. A rational number is a quotient of integers, which means there's some sort of division bar in between the numbers. So it is the set of all x such that x is a quotient of 2 integers. So that means the denominator can't be 0, because if we have a denominator of 0, remember that that fraction is considered to be undefined. So let's talk about lowest terms. Lowest terms means that the greatest common factor of the numerator, which is the top number in a fraction, so in this case here it would be 1, and the denominator, in this case here 2, which is the bottom number, the GCF of those 2 numbers has to be 1. So that brings us to this fundamental property of rational numbers. So I at least want you to have exposure to this. It says if a, b, and k are integers, and b does not equal 0, and k doesn't equal 0, the reason we're doing that is because those 2 guys are in the denominator, then the following is true. What this is saying is that there's some number, k, that we could multiply by a and b. So for example, if I have 36 over 54, I could say that that is 2/3, and multiplying the numerator and denominator each by 18 gives me that 36 and 54. So in this case, k is 18. Let's look at how we'll apply this fundamental property of rational numbers to make lowest terms easier. So let's go back to that 36/54. Most of you would not immediately start with 2/3. Your first step would be to find that GCF, and you would actually be working backwards to divide it out. I think most of you prefer the Euclidean algorithm, so that's what I'm using over here to find the GCF. So we said that the remainder before 0 is the GCF, so in this case, there's your 18. And what we would do would be to take the 18, and we're going to divide 36 and 54 each by 18. And that gives you your 2/3. We could do the same thing here with 16/48. If I use that Euclidean algorithm, we can see here that 16 goes into 48. So if we divide each of those guys by 16, we'll end up with 1/3. And you can also have negative numbers. So here's another scenario where each of these guys can be divided by 8, and we end up with negative 1/6. So be careful in your homework that you deal with your negatives correctly. So I'm going to go ahead and switch gears now and talk about multiplying rational numbers. If we're multiplying rational numbers, then we've got 2 fractions that are being multiplied together. And if you look at this definition here, and if I just look at the numerators, you can see that basically all that's happening is that we're multiplying straight across. I am going to make a note, and we're going to do this in the examples, that it is sometimes easier to look for a GCF diagonally to make your numbers smaller before you multiply straight across. This will be especially important in your homework. So let's look at some examples here. First of all, let's look at negative 2/4 times 3/9. If we look diagonally, there's nothing that goes into 2 and 9, and nothing that goes into 3 and 4. So when I multiply straight across, I get negative 6 over 36. And remember, we've got to reduce for final answers in MyLabs Plus. Here, in the second example, same scenario. There's nothing diagonally that can simplify, so we're just going to go straight across, and we'll get 3 over 40. This is nice because it doesn't need to be reduced. Now, one that may need to be reduced diagonally first would be something like 5/18 times 9/25. You can see that those numbers would get pretty large if we multiplied straight across. So if I look diagonally, 5 goes into both of those numbers. So I'm going to divide 5 out of each of them. And 9 goes into both of these numbers. So I'm going to divide the 9 out of each of those. And then multiplying straight across with the red numbers gives us 1/10. And that may be an important strategy to use in your homework. So switching gears now to dividing rational numbers. This is going to work pretty similarly to multiplying. There's just one extra step. When we divide, it's the same as multiplying by a reciprocal, and that's what this definition down here is saying. If I have 4 divided by 2, that gives me 2. And if I take half of 4, that's also 2. Those two things are equivalent. So if we're dividing rational numbers, you're going to keep the first fraction the same. In this case, it was a over b. And if you look at the second fraction in the definition, we have flipped it and found the reciprocal. So let's look at 2 examples. We're going to take 4/5 and leave it the same. And then I'm going to take the reciprocal of that second fraction. So the 7 is going to become the numerator, and the 24 is going to become the denominator. I still have to use my strategies for multiplication. Look diagonally first. 4 goes into both of them, so I'm going to divide the 4 out. And I end up with 7/30 as the final answer. In the second example here, I'm going to keep that first fraction the same, change it to multiplication, take the reciprocal of that second fraction, so the 3 becomes the numerator and the 4 becomes the denominator. And again, I'm going to look diagonally. 4 goes into both of those numbers, and 3 divides into 3 and 9, so that becomes a 1 and a 3. And now multiplying straight across, we get -1/3. I'd like you to take some time to practice with this.